Today we are going to talk about vents, and we are going to talk about the airflow on the installation of air conditioners. It's very important to know that restriction causes noise, and restriction will eliminate the efficiency of any unit in the market. New units right now, they have a lot of CFMs. CFMs are cubic feet per minute of blowing air, and less restriction, better it is. Like this little unit is 4,200 BTUs. It sounds like an airplane. Look at that vent. You will push that vent like crazy. So, of course, you can have different modes. You can have slow speed, the slow speed in this case. So it makes no noise, but there is enough static pressure that is moving this vent all the way forward. So, but it's not making that much noise. Air is funny. Air, it's always like a ball of ping pong. If you throw that air right on that wall, it's going to bounce back to you. If you throw that air in 45 degrees, it's going to bounce on 45 degrees and 90 degrees on the other side. So you never have to direct the air toward a wall in front of you, because that ball is going to come back to you and is going to join the other balls, and it's going to make a lot of noise. Plus, it's going to kill the efficiency of that blower. I can give you all the CFM, I can give you all the static pressure. I'm an expert. I'm the one manufacturing those blowers, and I did as much as I could for everybody to get an efficient unit. But I want them to work it out on the sense that nothing has to be a wall. Everything has to go with the flow. Now I'm going to go on a board that is going to explain a little bit more the situation. You have boxes like that are blowing directly into the vent. Those are the most efficient system. But you don't have that distance all the time to be able to do that. So you have to come on this side, and that's going to be a wall on the opposite side. So you have to have a box that is going to bring it around, because the static pressure is going to be in this location on the opposite location. But those are the vents that are the most efficient in any kind of build. If you can manage to do wonderful vents like that are direct flow, nothing is only the opening and closing into those valves, but most efficient vents are the one that is really connected directly to the dock. You see, when you're doing a ring and the decoration around them, and you're putting wood or you're putting all that kind of thing, they are very nice looking, and they are the most economical in the market. They can be closed, but basically they create no restriction and no noise. Those are amazing vents. Now we are going to talk about returns and discharge and the things like that. Okay, we are going to I will try to explain, let's say on a boat. Too bad this boat is so low that I have to go on my knees. But let's say that that's the bottom. We're having a flight bridge set up into the deal. top of the fly bridge again, and some kind of a setup like that. Some builders will create a soffit in this area to be able to blow the air, and they are going to blow the air toward the back of the boat and return in this direction. This is really fine and dandy, but there is no reason for them to have the units here in the middle of nowhere and to dock this thing all the way there. It makes no sense. The box is open, you're returning within the fly bridge in there. So it's hot air, it's inefficient, it's not practical to do in that. So if I'm going to do this again, the windshield and this location, that box that is in here, you could do the box this way and you leave that area. You have a way to mount this thing in different location, and you have your air that is like that, and you don't have a vent that is so ugly. On some boats, I saw even a compass sitting in the middle in here, but since the helm is not in the center, that thing, those two vents are not even in the middle. So that part, the return should be like an indirect return. You have an opening in here. You close the top of, you close with furrows and things like that, the fly bridge in the front, and you mount the air conditions in here, and this you can remove. The air conditions is in here, and naturally is going to return on the openings that are in here. When you're talking about the floor into the opening, you know, there is always leaks in fly bridge and things like that. So I always recommend that they have to mount this kind of a ring. They will put some 5200 of some silicone, and they mount this thing. If you have some kind of a ring, some kind of a leak in the fly bridge, it will not come in the salon. You can even make them bigger than that, but you have to have at least this to protect what is out there. The fly bridge, some manufacturers are really keys and the things like that, but doesn't matter. I just want to protect everything that goes in. But you see, if this thing is mounted in this location, you will have, and this is all closed, you will have all that area taken care. Now that we are talking about return air, here's my windshield. You can, the return air, you don't have to do it like that. You can also do it mounted in here, and you can have an opening that is in the front, and you have another baffle in there like that. You don't see the thing, and the air is coming in, it's going down, and it's going up through that thing, and it doesn't show. You don't need vents. Vents are not necessary. The air condition got their own filters in there, and you can clean the filter much easier than that by leaving an opening in there, or having those that wall removable. That's how the people are going to service the unit. But you have an area in here that is completely enclosed, and the air conditions are going to be there. If that soffit is there in other location, that's the floor, that's the whole thing enclosed. The unit will go somewhere in here in the other location, and we'll have the discharge that I was talking about later on, and you are going to have the duct going into that soffit that is on the side of the boat that is going all the way back and things like that. But the soffit on the boat has to bring the air. So they will go like that, they will go with the duct, that's the duct, and they will stop right here and they will blow through that. On the inside side of the boat, it has to be, if I cut this thing and I have the opening and I have that soffit that is like that, I need to have an opening like that, and I'm bringing the air out. When you're bringing the air out into this thing, first of all, you don't want to see the inside, so you have to have a second wall in there. But you cannot make the air go out when you have blockage. So everything has to come with an angle of taking them there, so the air will flow out. Nothing has to be, no angles, no openings like that, and another opening flat in here, and the thing flat in there, because the air is going to go there, it's going to bounce back, and it's going to create noise, and it's not going to come out. You have to make it flow. Everything has to be flow. It has to be taken out. And that's the explanation that I have around vents. One case that I had, for example, on a crew quarter. The crew quarter, the cabinet was here. The cabinet was here. Wonderful cabinet, opening on the bottom. And that was a closet. Beautiful closet. In the inside of that closet, they had two lengths like that were going all the way to the bottom. They put the unit somewhere in here, facing back or facing front, however they wanted to do it. But they did that. They did a T. Wonderful setup. And they went here, and they went there, and they went here, and they went there. That's in a crew cabin. That was the vent. They did an opening here, they did an opening here. And they did a wonderful unit. I believe it's like a 10,000 BTUs. The problem is, they are thinking that air is going to go there, is going to bounce back, and is going to continue playing that game, and little bit is going to go here, and he's going to go there, and he's going to bounce back, and then it's going to go out. We're not talking about water, we're talking about air. Air doesn't work that way. You have to have a buffer here that is going to take that air out, and it cannot have any place, because the static pressure is really on that location of the duct. I'm just going to go this way. This is the opening that they did. The opening of this thing, to make it clear, it has to be something you have to put in here to take it down. You cannot let it hit on that thing. Something needs to be done here the same way. Now we are in business. The air is going in here. Now you cannot let it go that way on the trap. You're not dealing with water, you're dealing with air. Air is funny. So you go out there, you go out, and you have another piece of material. It could be a piece of wood, it could be some door skin, it could be painted black, it could be nothing. But it has to make the air flow. Same for this side. You don't need to have it wide. You don't need to have anything because the air is really in this location. I'm just going to draw where the air is going to go. It's going to blow that way, and that air is going to try to go straight, but this thing is going to make it point. It's going to stay here, and then it's going to flow back and the thing like that, and finally the air is going to be here. So if you have a vent, a ridiculous vent of that distance, basically the vent is going to use only that because the pressure is going to be right on top of this thing. This unnecessary vent is not because you make it big that the air is going to flow out. The air is not going to. So you don't have to make a big vent. You can have a small vent in there that is going to flow, and that's going to go all the way to the technical room on the other side, and it's going to have a lot of air. Like I was showing you with a little 4.2, what I can move a vent. In that thing, nothing's moving. Toward the bunk that is in here, you are going to do the same. The air is going to go there from the blower, in on that area, in here, it's going to flow, 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 flow. And in this location, it's going to take it down, and it's going to come out. You will have the same results in a 4,200 or a 7,000 BTUs than your 10,000 or 12,000 that you put in there that is not cooling the area because that unit is looking for protection. That unit is in trouble. It's producing those BTUs, but you cannot remove the BTUs because your ductwork is not adequate. I hope you understood, and I hope you will do the same for the other cabins. Thank you very much.